Okay, so we've been through our covalent bond stuff. I put in quiz scores from yesterday. They were pretty good, actually. Most of you did very well. I'm going to give them back to you tomorrow. I had a bunch of people absent for ag stuff yesterday. So I'm going to give them back to you tomorrow. I would suggest that you hold on to them. The quizzes, we have 4 little quizzes throughout this unit. That's a great way to study for the test. It'll kind of mimic what's on the test. The test is a little harder, but this is a good foundation. So we've done our stuff with covalent bonds. We're going to talk about ionic bonds and ionic compounds and making them, and then we'll move into a lab that lasts about 3 or 4 days where we put all of this stuff to use. But let's start by talking about ionic bonds. This is a bond where there is a complete transfer of electrons to create a neutral compound. Ions are created in the process of compound formation. So I use that word ion. We've had it before. You should know what it is. Maya, what's an ion? How would you define it? Very good. An atom with a charge. And then you should know how many types of ions are there. Tristan just told me 2. See if you can name those 2. See if you can remember. I would think you could. We've had them several times, plus some of you, well, some of you have had them before. I don't know if you had any of these things in 8th grade or not, 7th grade or 8th grade. I don't know. Doubtful that Mrs. Gillen did any of this.
I think they mentioned it, but we never.
Yeah. Katie, tell me what they are. Cation and anion. Very good. Now my next question would be, which one of those is positive? Chris? Cation. So this is a positive ion, and this is a negative ion. So if I have a cation, I would say an atom with a positive charge. If I have an anion, I would say an atom with a negative charge. Now think about this. If I'm an anion, do I become an anion by gaining or giving up electrons? Gaining. So here I gain electrons, and up here electrons are lost. All right, pull up your periodic table because I'm going to ask you a question. You're going to want to look at it. I'm going to have you fill in these blanks in just a minute. All right, so metals form one kind of ion and nonmetals always form another kind. See if you can figure out which one of these is a cation, which is an anion by looking at your periodic table and what you know. When you've got it, fill in the blanks. Try to fill them in. Got it? Check with your lab partner. See if you agree. Okay. I heard someone say it. I think it was you, Luke. What do metals form? Cations. If you look at where they are on the periodic table, you should be able to figure that out. Which means that nonmetals form anions. Okay. So we can make this a little more clear, and we can say ionic compounds equal, I should say, an ionic bond between a metal cation and a non-metal anion to form a neutral compound. If I say neutral, what's the charge of neutral? Zero. So the compound charge equals 0. We want it to balance out. And there are just a few rules we have to follow when we make these compounds. We're going to start with the easiest ones first. Making monatomic, when you see that, think PT. Yep, thank you. Making monatomic compounds, or I should say ionic compounds. When you see monatomic, that means one atom. Those are the ones we go to the periodic table for. Some rules to follow when you write these. The cation is always written first. The anion is written second. The anion ends with always IDE if monatomic. We're not even going to worry about polyatomic today. And then the fourth thing we've already said, compound charge must equal 0. Now, I'm going to add number 5, and there are a few instances where it's going to show up, but I'm going to say prefixes are rarely used. Now think about that. In our covalent compounds, we use all kinds of prefixes. So it's another way to tell them apart. Rarely would you see a prefix in an ionic compound. I'm going to do nothing with this to try to trick you. So if you see a prefix, you should key in right away. Oh, that's a covalent compound. And the last thing would be metal plus nonmetal, which we already know. And now we're just going to practice with them. And I'm going to caution you now. Be sure that you get this today and you understand it. And if you don't, come down here for help, because this builds. It'll build for about 3 or 4 days, and it gets a little more difficult as we go. So if you miss it in the beginning, it makes the end really hard. So ask questions when you need to. All right, so let's just make one. Let's say, I'm going to give you this. Lithium chloride. Notice there are no prefixes. I have 2 atoms. They're monatomic. It ends with IDE, so right away I should know that's an ionic compound. When I figure out I have an ionic compound, I want to go to my periodic table and I want to figure out the charge. And let's look at that for just a minute. If you need a new blank or would like a new periodic table so you can make this clear today, I laid some out if you want one. The first thing we should do is go through and write how many electrons are in the outer shell of what we know. This varies. Okay, so I've got 1 electron, 2 electrons, 3, 4, 5, 6, and in group 17 I have 7. We already know that, right? We've been through that a few times. Now, a long time ago we made a table where we put the charge of the ions. I don't know if that's the one you have out or not. But if I'm in group 1 and I have only 1 electron, it's easier to give up 1 electron than it is to get 7. So these guys will form a 1 plus ion. When I go to group 2, it's easier to give up 2. So they form a 2 plus. Now, do you remember what happens to these guys in the middle?
Ionic stock system.
What?
They just fall like the ionic stock system.
Yes. Okay, so these guys are always cations. And we name by the stock system. What's the stock system? Do you remember? How does it tell me the charge, Lily?
I have written on here transition metals to ions and then it goes into the stock system data.
Okay, so stock system is Roman numerals. That's why we wrote those down the other day. Roman numerals tell the charge. And we'll do one or two of those today so you can see what I'm talking about. All right, then I get down here. I've got 3. Easier to give up 3 than gain 5. So these guys form a 3 plus. Then I get to this row that carbon's in. They have 4 in their outer shell. It's not really easier to gain 4 than it is to lose 4. So they will form a 4 plus or a 4 minus. Whoops, 4 minus. Circle your 4 plus. That's the most common. Now I get to the one that has 5. Once 8, so it's easier to gain 3 and be a 3 minus than it is to lose 5. Same way with the 6, easier to gain 2 than to give up 6. And in the 7, easier to gain 1 than to give up 7. So now you are responsible for being able to look at a periodic table and know the charges. Okay? Oh, one other thing I want you to mark off. I want you to start at aluminum, through zinc, through silver, then go this way. We're making a right triangle. Cadmium, indium, and then connect them. So you should have a triangle. This is called, and I'm going to write it on the paper so you can see it better, ALZNAG, and then this would be CD, and this would be IN. And this is gallium. Okay, so when I draw this, it's not as pretty as what's on the periodic table, but I still get a right triangle. This can tell me the charge if I can remember. Group 13, where aluminum is, has what charge? This is 3 plus, yes. Zinc is always 2 plus, and silver is always 1 plus. Cadmium is 2 plus, and then these guys are all 3 plus, 3 plus. It's called the magic triangle. I don't know why they called it that. It's not really magic. But if you can remember 3, 2, 1, 2, 3, then these are things you will always know. And I expect you to know these. You won't be given a stock system with those because they don't change. Okay, so now let's find lithium and chloride. Find lithium on your periodic table, Li, and chlorine, which is Cl, and give them their charge. What's the charge of lithium, Aaron?
1.
Yep, good. So 1 what? 1 plus or 1 minus?
1 plus.
Okay, so I would write a plus. And chlorine is what, Owen?
1 minus.
1 minus. And remember, my goal is 0. So when I do this, if I take 1 plus plus 1 minus, what does it equal? 0. We started with a really easy one. That tells me I only need one of each. So I write LiCl.
Oh, are we gonna start balancing equations now?
What?
Are we gonna start balancing equations now? With the cat?
Well, after we get through this stuff, we will, yeah. So let's try one that's harder. Oh, no, I know what I want to show you first. The Lewis structure. How you do that for an ionic compound. So let's use what we just had. Lithium plus chlorine. The way that I show this is, it's pretty similar to what we did with covalent, but I think about how many electrons they have in their outer shell, and I have to show them. Lithium has how many electrons in its outer shell, Jocelyn? One. Good. So I put 1 right here. And Austin, how many does chlorine have in its outer shell? 7. So I'm going to show those. And then this is an ionic compound, so I have a transfer of electrons. We know lithium becomes Li+, so it's going to give up an electron. It's going to transfer it to the chlorine. So when I write it on the other side of the equation, I write Li. It's given up its electron, so it's got a positive charge, plus chlorine, which got its electron. So now I show chlorine with 8 electrons instead of 7. It gained an electron, and then it has a minus sign. We don't put them together like we do with covalents. We just show the transfer of the electrons. And this actually represents the ionic compound LiCl. All right, let's try another one. Let's try magnesium nitride. And notice there are no prefixes here. So I go to my periodic table and I find magnesium, and I find nitride is from what atom? Nitrogen. And I find nitrogen and I give them their charges. Caitlin, what's the charge on magnesium? Good. 2 what? Plus. And the charge on nitride is what, Abby? Okay. So now let's look at this. Does a 2 plus cancel out a 3 minus? No. When they don't cancel out, the first thing you want to ask yourself is, what is the least common multiple, or the lowest common multiple? If you remember from grade, what are you saying back there, Chris? It's 6. You multiply them together, you get a number. So my lowest common multiple is 6. I say to myself, what do I have to multiply 2 by to get 6? Maya, what do I have to multiply 2 by to get 6? 3. So this is a times 3. That gives me 6 plus. So I would write that, if it's times 3, that tells me there are 3 of them. Mg3 is how I would write that part. And then I say, what do I have to multiply 3 by to get 6? Katie Paulus just told me 2, so times 2 gives me a 6 minus, or so down here I write N2. So now this represents a 6 plus, and this represents a 6 minus. If I add those together, I get 0. Now, look at what just happened. Kind of cool. My superscript here became my subscript down here. My superscript here became my subscript down here. It always works. Except for the thing that you have to remember is they must be, and you always ask yourself this, must be in most reduced form. So I say to myself, can I divide both of these by 2 and get a whole number? No, this would be 1.5, and I never have a subscript that's not a whole number. So this can't be reduced any further, right? So it worked perfectly with this one.
We're not splitting.
What?
I said we're not splitting.
We're not. You're right. Okay. I don't want to split atoms.
Not a deal.
Let's try, you guys try this one. I'll let you try this by yourself. I want you to find the charges. I want you to make a neutral compound, and when you're all done, stand up. Okay, find your lab partner and check with them. If you don't agree, talk about it. And then if you don't get it, you need to ask questions. Yes, it is.
I feel like this is the thing I want to be the best at in this class. I was good at it last year. That was when I first learned it.
Okay, come back. Either you agreed or you didn't agree. So I have the correct answer written up here. If you didn't get that, you probably should have a question. Raise your hand if you got it. Okay. Raise your hand if you have a question. If you didn't get it, do you feel like you know now why you didn't get it? Then I'm going to give you another one to try. Try, let's see. I'll do this. Lead 4 sulfide. What does this mean? Gives me the charge, doesn't it? Yes. See what you can come up with. When you're all done, drop your pencil. Then I'll know we're all, well, you don't have to drop it now. I know who's done, but if you guys are finishing up, put it down. You don't have to drop it. You're so literal. Okay, so let's talk through this. This one you got to think a little bit more about. PB, this Roman numeral is 4. It tells me it's first, so I know it's positive. So this is 4 plus. Then I can go to my periodic table, I can find sulfur, and I can figure out that it's S2 minus. Now, can I do the switcheroo here? Can I go PB2 S4? I can, but then I have to ask myself always, what's wrong with this? Is this in most reduced form? No, so I would have to get it in reduced form. What am I going to divide through by? 2, which makes it PBS2. How many of you got that? Okay, good. If you have questions, ask now. Katie Paulus, any questions? You got it now. Okay, so I'm going to give you another one. You have to use the magic triangle for this one. Woo, big excitement. Silver phosphide. Abby, what's the charge on phosphide? 3 minus. And my charge on silver, I should know by heart. What's my charge on silver? Seneca. 1 plus. Now, let's check this. Can I do the switcheroo here, down here, and down here? Can I say Ag3P? I can, and I can't reduce it any further. Now, this is what I'm going to do. I'm going to give you 3. And I want you to find a good partner, and I want the 2 of you to work through them together, checking each other. And call me over if you're confused. I'm going to give you 3. Put them right in your notes. First one, lead 3 chloride. Calcium arsenate, tin 4 oxide, and then I'm going to give you one other thing. Eyes up here for a minute. I'm going to give you, wait a minute, let me grab a periodic table. I'm going to give you Cr2O3, chromium oxide, and I want you to figure out, find the charge of chromium, and I want you to write it in stock system. Write the name of the compound using the stock system. Try that. That's probably the biggest challenge. This one right here. As you finish one, call me over. I'm just going to rotate about the room. Candace, come see me in the morning if you have questions. Oh, and Lily's going to send you a picture that you need to pull your cards out from.